Hello, I welcome you all to this another interesting screencast. The problem reads, if the coefficient of static friction at all contacting surfaces is mu s, determine the inclination theta at which the identical blocks each of weight w begin to slide. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so we are dealing with dry friction. Okay. And in this particular problems, we are going to experience three types of problems of dry friction problems. The first one is where we experience no impending motion. This is where you have no impending motion at all the contacting surfaces. And in this particular case, you expect the number of unknowns, okay, are less than or equal to the number of equations of equilibrium. So once we've done so, then we need to check for the contacting point or surface, whether this condition is met. And if it is met, then we are sure that there is no slip at those two contacting surfaces or points. The second type of problem is where you have what is called impending motion at some points, okay, or surfaces. These are contacting surfaces. And in this particular case, you expect the number of unknowns to be greater than the number of the equations of equilibrium, okay. And in this particular case, you expect to invoke or to use additional equations, which are the friction equation, okay. For those other points where you don't use the friction equation, you need to check for slip, like we did in the first type of problems. The third type is where we have again impending motion at O. This is at all points, surfaces. In this particular case, we realize to say the number of unknowns usually are going to be more than the number of the equations of equilibrium. Okay. And in this case, of course, we'll be forced to use also the friction equation, F equal to mu n. Right, basically this is about it. So let's dive into this particular problem. Alright, so we have two blocks, and these blocks have equal weight, and they have equal coefficient of friction between the contacting surfaces. We have two of them. We have between B and B, A and B, and between B and C. Let's call this other contacting surfaces C. So we are going to have two cases here that we're going to check for. In the first case, we are going to assume that block A is moving in this direction as block B is moving in that direction. Okay. In the second case, we are going to assume that block A is moving in that direction as block B is moving in that direction. Okay. Of course, let's draw the free body diagram so that we check for the unknowns. Alright, so there we go. Something like so. Okay, let me draw it like so. Great. Alright, so one block and another block. Great, this is good enough. Okay. Right. There we go. So let's say we have the weight there. So let's say we have the weight at those points, right? And then we are assuming that we are assuming that at these pulleys, no friction, no friction at the pulleys. Okay, both pulleys, so we expect the same tension. This T is the same here, T there, it is the same T, right? So here you are going to have 2T, while here you have just 1T, right? Is that fine? Of course. Great. Okay, so we are saying here we are going to have just 1T, then here we'll have 2T. Okay, right. So we are going to have two cases like we said. So the weight, this weight is going to have two components. It is going to have one component like so. It will have one component like so. And then it will have another component like so. Mind you, our coordinate system is like this. So this is the coordinate system that we are using. This is our X, this is our Y. Okay. Alright, and then we'll have also here another component like so, and there we'll have a component like so. Okay. Of course, the first case we said A will be moving in this direction. So if A moves in this direction, we expect friction to be in this direction like so, and then we'll have the normal force like so there. Alright, then the same normal force will be the same there. And then here, since we are assuming this to be moving in this direction like so, this is case 1. So we expect friction to be in the opposite direction like that, right? Because friction, this is the force that resists the movement of two contacting surfaces that slide or move relative to each other. Okay, and then of course these two, they must be always opposite and equal, right? This set. Then friction here at the bottom here, of course you expect it to be in this direction like so. Okay, and then you have the normal force like so. Okay, you have the normal force like so. Alright, and then let's say there we go, we have this distance here, and also here we have this distance here like so. Alright, we are not going to calculate those values, we are just showing them. Let's call this point, of course this is block A, this is block A, this is block B. So we are saying this is XA, this is XB, this is NB, this is FB. Okay, this is FA, this is NA, this is FA. Alright. Of course this angle here is theta, and so is this angle here. Okay, and this is W, and this one is W there, and this is T, This one is 2t. And then you have this one, which is w cos theta. Then this one you have w sine theta. Okay, this one you have w cos theta. This one you have w sine theta. All right, so we've drawn. So this is case 1. All right, we'll change this case. So let's go to case 1. Case 1. So this is where you have A, you have A in this direction, you have A in that direction, tends to move in that direction, then you have B in that direction, tends to move in that direction. Okay, so this is case 1. So let's start working on case 1. So let's start with summation of forces in the Y. Summation of forces in the Y. Of course, let's go to block A. We go to block A. So summation of forces in the Y equal to 0, going up in our reference, not really up, is inclined, going in this direction. Okay, positive. What do we have? We have minus W cos theta plus NA equal to 0. Therefore, our NA is just going to be equal to W cos theta. Alright, then we have summation of forces in the X equal to 0. Of course, going in this direction, in our reference, in this direction like that. Right, what do we have? We have FA plus minus W sine theta and then plus T. So we have 1, 2, 3. Okay, so this is equal to 0. Therefore, our T is just going to be equal to, mind you, I didn't count the number of unknowns. So the number of unknowns, let me write here. So number of unknowns, how many are there? So we have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. This is FA, FB, NA, NB, T, XA, XB, theta. And then number of equations of equilibrium, how many are there per each one? There are going to be 6. So we need FA also to be equal to mu S NA, and FB also is just going to be equal to mu S NB. So we need these equations 1, 2, 3, 4, 5, 6, 7, 8. All right. I do want to find theta. So that is the number of unknowns. So that's the reason why we've employed these two friction equations. So this is type 3 problem. Okay, all points. Okay, we are assuming all points are doing what? They are moving. Right. Let's get back to our equations of equilibrium. We are saying T T therefore will be equal to W sine theta and then minus FA, and FA is equal to 0.3, sorry, not 0.3, we don't have any numbers, is equal to mu S NA. We said FA is equal to what? So we said that FA is equal to mu S NA. Alright, so this one becomes mu S NA, and NA is equal to W cos theta, so this becomes mu S W cos theta. So this is our T. So we are done for block A. Let's go to block B. Alright. Block B. Of course, here we also know that FB is equal to mu S NB. So let's say summation of forces in the Y equal to 0, going in this direction, which is our positive. So what do we have? We have minus NA, okay, minus W cos theta. What else? Then plus NB equal to 0. Therefore, our NB is just going to be equal to NA. What is our NA? Our NA is W cos theta. So this becomes W cos theta. Alright. Plus our NB. What is our NB? Our NB is, where is it? Our NB is, do we get, oh, we want NB, sorry, plus W cos theta, sorry. So this is going to be equal to 2W cos theta. How come I'm looking for what I'm finding? So we have NB there, sorry. Then we have summation of forces in the X. Of course, this is our reference. In the X, so we have minus FA, minus FB, minus W sine theta plus 2T equal to 0. Right? Is everything fine? I think so. So we have 1, 2, 3, 4. So we know what FA is. Let's write this. So this becomes minus mu S NA, and our NA is just W cos theta, then minus mu NB, and our NB is 2, so this just becomes 2. This becomes 2 mu S W cos theta, then minus W sine theta, then plus a T. Our T is this one here, so this becomes 2 W sine theta minus 2 W mu S cos theta. Alright. W mu S W mu S 2 mu S W cos theta equal to 0. Write this. Okay, let's let it go the other side. So we are going to have W sine theta then equal to the other side. When they add, it becomes 5. So 5 mu S W cos theta. When we divide through by cos and W, this becomes tan theta equal to 5 mu s. Therefore, theta will be equal to tan inverse of 5 mu s. Alright, so this is the first case. So our first case gives us promising results. Let's check what we have on the other side. It's not bad to check. So in the second case, we are going to assume. So in case 2, we are assuming movement like so, and then this one we are assuming movement like so, and then this arrow changes, friction changes here. It instead goes like so. Alright, and then this arrow also changes here. It becomes like that. Okay, and also this arrow changes here. It becomes like that. That's case number 2. Okay, so this is case 2, where we are assuming A moving in that direction, A like so, and then B like this. Alright. Okay, so block A. Let's start with block A. Block A, what do we have? Most of the things won't be very different. The equations will be more or less the same. So can I copy these? These equations won't differ so much. I bring this. Let me get rid of this. Only few signs are going to change, so I bring this one here. Alright, so which sign is going to change? The y's are going to be the way they are, but the x, w of course, then here we are going to have a minus. FA, let me check FA. FA will have a minus. Alright, so that this one here becomes, T becomes a plus, like so. Okay, so this is the change here. T will change, and then for the other part, we also need to copy this. Not much again will change. We bring it here so that we don't waste so much time. We are just checking, okay? There's nothing wrong. So this one, this is our positive going like so, and this one is our positive going like so. So the y's again here won't change. Y will remain the way it is. X will change. So these are going to be positive. FB and FA will be positive, these values. So this one will be positive, and this one, W sign will maintain the way it is, and therefore this is positive, and this is positive, just these two. The rest remain the way they are, and also this one T here is a positive, right? T we said is also positive, like so. Okay, So now let's see what this becomes. What do we have? Let's see what we have. So when those are positive, this and this and this, this and this and this, they become 5. So we'll have minus. This one becomes plus. So we are going to have minus w sine theta equal to 5 mu mu s w cos theta. Right, when we divide through, this becomes a tan theta equal to minus 5 mu s w, and we divide through by cos, and w cancels out, and then we have a minus like so, tan inverse of minus 5 mu s, and we know that mu s can never be negative. We know that mu s can never be negative. Okay, therefore this part falls off. Therefore the solution becomes this part. Okay, so this is the final solution. This is the final solution. So this is the value of theta when we expect the two blocks to begin to slide. But here we are going to have case 1 where block A will be sliding downwards. Okay, as block B is sliding upwards. Okay, so this is the case that is going to take up the day. All right. So I think this is about it. And I hope this video was helpful, and if it was, give me a thumbs up. I like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.